All right, it's recording exercise 1F, inverse functions. You need exercise 1B and 1C notes to understand. So here we go. For a function to have an inverse function, which I highlighted the word, it must first be a 1-to-1 function. So if you did 1C, then you understand what a 1-to-1 function is. If it's not a 1-to-1 function, you will not have an inverse function. You will have an inverse, but it will be an inverse relation. Just as a quick, sort of for those who didn't learn it, but maybe have some quick understanding. The test for, let me test you guys actually. What's the test to test this quadratic? We know it's a quadratic function. What's the test again to know if it is a function or not? Yes, Lachlan. Vertical line test. If it crosses once, so VLT, vertical line test. If it crosses once, it is a function. So my notes for that exercise, it's a function if it's a vertical line, crosses once, so that's why we call that a quadratic function. But then, if I want to test if it's a 1-to-1 function, which line do I use? Hands up if you know. Noah. Horizontal line test. So if I use a horizontal line test, which I'll do, which color? I'll do red. If I do a red line, this crosses twice. So this is not a 1-to-1 function. So a horizontal line test tests if it's a 1-to-1. Okay? If it crosses twice, it's not. So this is considered a many-to-one function. Again, if you don't know what I'm talking about, go back to 1B, 1C. All right, so that's a quick way for you guys if you're doing 1F. Horizontal line test to test if it's going to be a 1-to-1 function or not. And the logic to this, if you think about it, if I asked you to draw an inverse of a quadratic, so y equals x squared, what's the inverse function of squaring? Square root. This is why in year 11, the first one you learned, or one of the first ones, is this is called a square root function. A square root function looks like this, like that. But if you really think about it, square root is the opposite of squaring. So if a quadratic looks like this, then a square root should actually be quite similar, but it looks really funny. It's only the top half. If you actually really think about it, it should be this included. Because a square root relation, well, why we call it a relation is because you've got a positive and a negative. This is the positive root version, and this is the negative root version. But you see, if I did a vertical line test on this one, is that a function? No. So one of the years they called it find the square root relation, and students are so used to thinking of a square root function, they were talking about this and their range was off. But it said square root relation. So it means that you needed to include both top and bottom, so hence the range was all real values. Okay, so that's the difference between the word relation and function. And that's an example. This is the inverse graph of a quadratic graph, but notice that this was not a 1-to-1 because this is not a 1-to-1. When you did the inverse, it also ended up not being a 1-to-1 function. Okay, that's why they say that you need to make sure it's a 1-to-1 first, because then when you do the inverse, what you're really doing is you're pretty much swapping the x and y. So 1x to 1y. If you swap it, it should be 1y to 1x. 1-to-1 is the only one that does that. So yeah, many-to-one, if you swap it, if this is your x and this is your y, many-to-one, if you swap it around, it becomes 1-to-many. It's not a function, it's a relation. And if you did a many-to-many, well, obviously, that's not going to be a function. And if you did, what's the other one? 1-to-1 will definitely work, and then there's 1-to-many. 1-to-many, but when you swap it, it is a function, but it is not a 1-to-1 function. Okay, so that's why. So if you didn't understand what I just described, it probably means that you needed to look at 1B, 1C. Okay, but to work on exercise 1F, if you just understood this idea and the horizontal line test, you should still be able to move forward. Okay, here we go. So what are we going to fill in? Formally, as an inverse function, this is what it's defined as. Okay, so we've learned, let's pull this out. See, my battery will last. If inverse of x is equal to y, and that just basically means the inverse will exist if f of y, so instead of x, if I substituted y, it equals to x. That is represented by this graph. So when you sub y, it equals to x, and when you sub x, it equals to y. There's that inverse relationship. That's what it's trying to describe. Okay, so that's a formal definition. This is our informal definition where we're talking about a horizontal line test, and it's one-to-one. Yeah? So graphically, as you can see, if you sub in y and it equals x, and if you sub in x, it equals y, and there's that inverse relationship or flip relationship, well then technically the domain, what was initially a domain for one graph, now becomes the range for the inverse graph. And same thing, the range for the original graph becomes the domain for the inverse graph. So here is the second property that they will test. But often you'll find that exams will test this first point. Okay, this is the other second property you should already know. The inverse function, the domain of the inverse is equal to the range of your original function. And then the range of your original function, the range of your inverse is equal to the domain of your original function. Okay? It's kind of like that x becomes y becomes x idea. All right? So what you see in the first box, that's pretty much what is examinable. Those are the two key points. If you get a multiple choice question, it's one of these two theories. Sometimes in an exam question, they might ask you to sketch it. So you see that graph? There's a mirror. This is like your reflection mirror. Instead of reflecting on the y-axis, instead of reflecting on the x-axis, it is the reflection on the y equals x line. Okay, and that might help you to sketch. I'm going to give you some tips later on how to sketch. Some of us are really good at it, and then some of us really struggle visually for it. So you might need to use a couple of things here to solve it. But let's go and start off with the exercises. So what is exercise 1F going to be about? Very simple. First thing is you need to be able to find the inverse equation. So assuming that this is a function, which they already told you, it's f, so it's a function. So you already know it's going to be 1-to-1 at least. So f of x equals to 3x minus 2 on 4. What type of function is this? We've got a hyperbola. It's linear. Okay, so I know it's a fraction, but if you really wrote it out, that's the same thing as saying 3/4 x minus 2/4. Okay, so it's a linear line. So we know it's a straight line, so hence why it's a 1-to-1. So obviously it has a inverse function. So find the rule for the inverse. Right here I wrote let y equal to f inverse of x. Remember the property was if you sub y it equals x, then you have an inverse for the equation. So what did I write here? So f of x needs to equal to x, right? So f of y equals x, and then what's this? Then f of y equals x for the, what am I talking about? Inverse function. What am I doing? So from here, now we begin. So because I already defined, I said let y, don't always just use y out of nowhere. I know it simplifies your calculations, but if the examiner questions did not write f inverse, if the examiner question or exam question says y, then you can use y. If they don't use y, you need it, and you use it, they'll penalize you. So you need to introduce it. So if you want to use y, do something like I wrote here, right? Let y equals to something so they know that you defined it. Okay? So from here, because I called y the inverse, I can now rewrite it as f of x equals 2. Instead of 3x minus 2, it now becomes 3 y minus 2 on 4, because this is me substituting y into where x is. Okay? And then obviously equals x is here. Okay, so I'm just saying if the inverse function does exist, then this property exists. F of y equals x. Okay? All right, here we go. So the y is meant to represent my inverse function because I said let y equal to the inverse function. So here I'm using y instead of f inverse. So here I'm going to multiply both sides by 4 for those who aren't really strong with their linear equations, fractions, times 4 because that's divide 4. 4 divided by 4 cancels out. You end up with 3y minus 2 is equal to 4x. Add 2 on both sides. You get 3y is equal to 4x plus 2. And then finally, y is equal to 4 over 3x plus 2 and 3. Don't leave your answer like that. If they ask you in your exam, so if the question asks you to find the rule or define the inverse function, so here, if the question asks you to define or find the rule, or it mentions to include a domain, you must write it in function notation. For those who don't know what a function notation is, from last year, you should have been introduced to it, but it should be F, you write your domain first, maps onto the codomain, which usually in methods we do R, and then f of x is equal to whatever it is, right? So in our case, it's an inverse function. You don't leave your answer with a y, because especially if it's an exam question, they don't use y. So from here, you rewrite it. So I'm saying f inverse is the domain. Now they've given us the domain. It's R, or it's actually range. So the domain of the inverse is the range of the function, and clearly it's a straight line, so it's also R. So here we go, R maps onto R, comma, f inverse of x is equal to 4 over 3x plus 2 on 3. Okay, I'm just going to put a note here so you remember this is actually the range of f equals to the domain of the inverse. Okay, and because I know it's a straight line equation, domain is R, so then the range has to be R as well. Okay? So far, so good? All right, that's exercise 1F for the first part of the skill. First part is just being able to rearrange, find the inverse function. Let's now go to the next part of the skill of the exercise. The other part of the exercise is you need to be able to sketch the inverse. Now, this does come up in exam 1 here and there. Sometimes they'll get you to find the inverse and then sketch the graph of the inverse. This is an example. And you need to kind of do it intuitively. So for some of us, this could be hard mentally. So here, I chose question 11A, C, and F because it's slightly different and you have to use some of the properties that you've learned so far. So to sketch this inverse, you know, a couple things. Well, only one thing really that's main. Domain of F inverse is equal to the range of the function. Range of the inverse is equal to the domain of the function. So essentially, I'm just saying y becomes x and x becomes y, right? So those are my coordinates. So if you were to visualize this, one of the tips I give to students, if you can't do it mentally, is you can turn your head on a side so that you can imagine that there's a y-axis this way. Okay, and then you want to draw it symmetrically, symmetrical to that. So imagine if I had to draw a symmetrical line, I can already see this point, it's going to go up like this. So that's symmetrical. And then here, I match that. Can you see what I'm doing? So I'm just kind of turning my head and I'm seeing that symmetrical look. The reason why this is more helpful is because even if you swap the x and y's, it's still 0, 0, and 3, 3. So unless you get familiar with how to do a reflection along the y equals x line, this is one of the tips I normally teach my students. I say turn your head and then you can kind of imagine there's a mirror here, because a lot of students can do vertical flips, horizontal flips, but when it comes to y equals x flips, it's somewhat a bit more tricky. So it might help if you turn your head on the side of it. Okay? So that's one, but let's say the other one. You can tilt your head and you might be able to visualize it right now. See if you can visualize what the inverse function should look like. What would the inverse function look like? If you can't, using this property could help. So this point is 3, 0. This point is 2, 0. So if you swap those points, so it becomes 0, 2 and then 0, 3. Oh, sorry, 0, 2. So that's 0, 2 there. 0, 2. So it becomes 2, 0 and the other one becomes 0, 3. It might be easier for you to visualize. Here is 0, 3. Here is 2, 0. That might help you be able to turn your head and kind of visualize what it should look like. Okay, so again, I'm using that property, what you learned from before. Have a go with the last one. I'm going to pause the video. Thank you for your contribution. Yes, this is the function if you were to guess it. Another way to kind of guess it is this is somewhat like a cubic graph, so x cubed. So the inverse of cubing is, not square rooting. Good, cube rooting, which is to the power of 1/3. So if you type in the power of 1/3, you should look this way. It's like the S version of the n version. Okay, so this is like an n, and then it's like an s. Or if you tilt your head, it's like a cubic version for the x-axis. It's another way of looking at it. Okay? So yes, that is correct. It does look just like that. Okay? Very good. So that's your second skill. And then putting all that together, using your understanding about one-to-one function and the fact that the domain becomes the range becomes the domain, then have a look at this question. This is a typical one that you see in a multiple choice question in an exam. So I like this one. I helped you by drawing the picture so you can visualize. And I even wrote this as a hint. Normally in an exam question, you don't have any of that. So that means you have to visualize it yourself. So I'm helping you already to visualize. So let's break down the problem. What's the problem? Let G, so that your function G, the domain is from B inclusive all the way up to 2. You've got a 1 minus x squared. It's a quadratic function, which I've drawn for you. If B is the smallest real number, so you want the smallest value that B can be. So what number can B be? But it has to be the smallest number, such that there is an inverse function. So I gave you the property already. There's only 2 things that the examiners normally test, one of which was the main key first line that I gave to you. It's a very quick answer. If you get it, you look at the graph, or you can visualize it, you will know the answer straight away. I'm going to pause the video. That I mentioned that the examiners are really just testing, it's just the one skill, it's normally a multiple choice question, is that they want to know that you understand when an inverse function occurs, and it's just when it's a one-to-one function. This is a quadratic graph, so automatically this is not a one-to-one function, this is a many-to-one. How do we know? I gave you the 2 tests before. Is it a function? Vertical line test is yes, it is a function. But if I do a horizontal line test, this is a many-to-one function, not a one-to-one. So the problem is the domain is from B, which we don't know what B is. It goes up to 2, so I already gave you the picture where 2 is. When x is 2, y is -3, so it stops here. The question is, what is the smallest value that B can be? Now, B can be here, B can be there, B can be here, but B needs to make sure that it is a one-to-one function. Okay, now B could actually be over here too. So B could have been half. Lachlan said 0. But B could have been half, but they said smallest. What's the smallest number? So what's the smallest number that if you had to draw a horizontal line, that it will always cross only once? See, this crosses twice, so clearly B can't be up to this point. What if I chose B in the negative region? Here, still has 2 intersections. The smallest point where you can only have 1 intersection is right at 0. See, so if I just drew the graph, it was only from this point to this point that the graph can actually be a one-to-one. If you even do a little curve across for part of the quadratic, then it becomes a many-to-one. So to keep it one-to-one, at the turning point when B is 0, all the way up to when B is equal to 2, anywhere there is possible, but they wanted the smallest B values, they had to be at B equals 0. So that links back to exercise 1A, 1B, domain and range, understanding what a function is, C, types of functions, and then now 1F, knowing what a one-to-one function for an inverse function would be. Okay, so it's a very simple idea, but it's, again, I drew the picture for you. If I didn't draw it, it adds another level of complexity that you have to be able to visualize that. Okay, so the answer clearly is, well, let me just fill in the blanks here. Inverse, there must be a one-to-one, and you use horizontal line tests to see if it's one-to-one. And clearly, if it's from x equals 0 all the way up to x equals 2, if you chose anywhere there, it'll always be a one-to-one. But what's the smallest value of x that you can choose? Well, the smallest x value has to be 0 inclusive. That's why for smallest possible. Okay, so that's a bit of a conceptual understanding, but that's understanding the theory. That's 1F. So far, so good? Okay, so I did 3 sort of variations of the understanding of one theory. It's one dot point in your study design, and that's what they do. They just vary the questions. Okay, I'm going to stop the video there. I'm going to give you, this is kind of 2:31, so maybe I'll give you 20 minutes. Yeah, I'll give you 20 minutes, so about 2:50. We will then go back, and then I'll do the first page of your 3ABC booklet. you fill in some notes. Okay, so you got 20 minutes to have a look at either 1F or any other exercises you're behind. Just make sure, just to get a general idea of types of functions, types of relations, and domain and range.